All right, hello and welcome. So this is going to be the first of a series of quick 5-minute-ish videos that kind of goes through the Unit 5 practice test provided by me during class today, Thursday, June 10th, just as you prep for that very last chemistry test of the year. Okay, so we're going to start with number 4, and that's because questions 1 through 3 were really just kind of simple multiple choice level 1 type questions. Number 4 is the first one where really some explanation is needed. Okay, so in this question, the idea is just to look at the various reactions, all right, and recognize based on the reactants and the products in those reactions how we might classify that type of reaction. Now, the purpose of knowing reaction types ultimately is being able to use patterns in these reaction types to predict products. But here, really just want you to look at the reaction, right, in terms of what are the reactants and what are the products, right, and using that information to decide what type of reaction it is. And we have 5 types, and these will not be listed on your test, so you need to know what they are. We have synthesis, decomposition, single replacement, double replacement, and combustion. Now, if you look at those and you have no idea how to tell which is which, okay, you need to go back to the slide where this link is posted and watch the Tyler DeWitt video, Intro to Reaction Types, right? And in that, he will explain how you can recognize each of these 5 types. Okay? If you already have those notes and you just want to review how it fills in with this particular set of questions, you can just stay right here. All right, now in this first one, we have C20H42 plus O2, right? So again, if you got your notes from the Tyler DeWitt video, you ought to recognize that this is a hydrocarbon reacting with oxygen to produce CO2 and water. We should immediately recognize that as a combustion reaction, right? Because our combustion reactions in the context of our class are going to involve hydrocarbons, so carbon, hydrogen, and sometimes a little oxygen, reacting with oxygen gas to produce CO2 and water vapor. This part of our combustion reactions always looks the same. Now, later on when we balance, we'll have some coefficients in there, but the plus O2 yields CO2 and water. That's a dead giveaway that it's a combustion reaction. All right, next one we have silver nitrate, AgNO3, and calcium bromide. So this follows that A, B plus C, D format, which yields C, B plus A, D, which would make this a double replacement. Okay, and again, if you don't have the notes or the information for how we can recognize that as double replacement, go back and watch that Tyler DeWitt video linked on the same slide you got this link from. Okay, now next one we have lithium. Is added to copper nitrate to produce lithium nitrate and copper. And so in this case, we have A all by itself plus BC yields AC plus B, which looks exactly like a single replacement. Okay? In this case, we are taking a single material with 2 parts, A, B, and splitting it into its constituent elements, A plus B, which would be a decomposition. All right, and in this case, we have A by itself plus B by itself combines to a single substance, making this a synthesis reaction.